Hey guys, today we're going to have day one of our review for the test. Remember, our test is on Wednesday, Thursday, Friday of this week. And so today's review is focused on solving equations, which is standard 4.1. This very first problem, which is asking you to solve this quadratic equation using factoring or the quadratic formula, know that you can use either one, right, for our problems that we're doing. And what I'm going to go over with you in this video is going to be the factoring method, because this particular problem, we haven't spent a lot of time going over how to factor problems that actually have a number in front of x squared. So that's what I'm going to pick for my method of solving this problem. I'll show you a little bit of how you would go ahead and set up the quadratic formula, but since we've done that many times, this method's going to be my focus for those of you that have chosen factoring to be your preferred method of solving quadratics. So the first thing we're going to do when we are factoring, as usual, is make our box and diamond. Alright, so most of the process is the same. There's just one small difference that we're going to talk about as soon as it comes up here. Okay, but for now, it's the same, right? The first term goes in the top left corner. The third term goes in the bottom right. Okay, and then we're ready to go ahead and fill in the diamond. So the top, remember, is the first term times the third term. So 6 times 9 is 54, and there's an x squared in there as well. So we are going to have 54x squared. And remember, we have to multiply to make 54. So that's why I'm putting a multiplication symbol there. And for the bottom of the diamond, we use the middle term here, as we always do, so 21x. And this is the one we have to add up to make. Okay, so now we are ready to play the game, and we have to ask ourselves, okay, what two numbers that multiply to make 54 also add up to 21? These numbers are a little bit bigger, so it might be a little bit challenging, but you'll get it with some trial and error. So at first you might be like, well, I know that 9 times 6 equals 54, and this is true, but then when you check to see if 9 plus 6 equals 21, you find out that it doesn't, right? 9 plus 6 is 15, and so the 9 and 6 do not work for our intents and purposes. We have to try something different. And then maybe you'll think, oh, well, I know that 18 and 3 make 54, which they do. So this is good. And then we have to test it out for the addition, 18 plus 3. And they sure do equal 21. So we're good to go. And that means we can use those two numbers, 18x and 3x, for the rest of our x, and then also the rest of our boxes. Okay, so this next step is really where there's some difference in the process now from the factoring that we're used to. Usually, when we do the outside of the box, we know that we have to make whatever is in this box by multiplying these two sides, which is why we always do x and x. You guys are really good at that, very used to it. But here's the thing. X times x does not equal 6x squared. So in this situation, that does not cut it. However, if we put a 6 on one of them, 6x times x does equal 6x squared. So now we have to decide, where can I put the 6? Okay, let's see what happens if we put it here. If we put it here, and then we try to fill out this spot, we would ask ourselves, okay, 6x times what equals 3x, right? But then you're like, but 3 is smaller than 6, I wouldn't be able to get a number here that's not like a decimal or a fraction. So because 6 doesn't go into 3, we do not want to put it here. This is not a good spot for it. Okay. Instead, if we put it here, we see that 6 does go into 18. So 6x times what equals 18x? Well, you would put a 3 because 6 times 3 is how you would get 18. Okay, so that's why you put the 6 here, is because it goes into 18. And then here, you just fill it out like normal. X times 3 would give us a 3x. All right, and once you've done that part, you would go ahead and set it up as usual. So we have a 6x plus 3, and we have an x plus 3 equals 0. Remember, when you're solving by factoring, you actually have to go past just writing it in factoring form. So like you have to set it equal to 0, each factor. So our zero product property. And the other little difference here is that some of us might be used to just looking at this and taking the opposite sign, which is fine in most situations, but when you look at this one, that doesn't really work, because now that there's a number in front of the x, you know, a -3 would not make this equal 0. So we actually have to go ahead and solve this one properly for x. So, you know, we subtract 3 from both sides, we get that 6x equals -3, and then we're going to divide both sides by 6 to get x by itself. So you find out that x is -3/6, which is fine. If you simplify it, you would get -1/2. Okay, and this is your second answer. So we have an x answer here, and we have an x answer there. All right, that is how you would solve this problem by factoring. If you wanted to do it by quadratic formula, I'll just do a small setup over here. Quad form. You would do that one formula, which is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's what the quadratic formula is. And we know that our a is 6, our b is 21, our c is 9. All right, so again, what I'm doing now is just starting to show you the other method you could use to solve this problem, as you guys know, or should be familiar with. So if I wanted to do it with quadratic formula, I could plug in my numbers. So I would have -21 plus or minus b squared. So 21 squared, and the numbers are going to be a little bit big here, minus 4 times a minus 6, c is 9, all over 2 times 6. All right, and then you would continue simplifying from there. And you would get the same answers that we got over here, which is -3 and -1/2. All right, and again, this is just in case you wanted to use this method. Okay, so for the next problem, this is just a big old linear equation that's a bunch of simplifying and then isolating x. So the first thing we want to do here is go ahead and distribute anything there is to be distributed. So this 2 should distribute into the parentheses to make -8x, because 2 times -4x is -8x. 2 times -7 is -14. And then the plus 6x is just hanging out. Nothing to do on the other side, so just leave it as is. And let's try that again. That was kind of ugly. Okay, so now we can start to combine like terms. We know that these two x terms can combine on the left, so that's going to become a -2x. The -14 is just going to stay the same. Nothing to combine on the right side still. Okay, now we want to get our x terms together. So what I'm going to go ahead and do is I'm going to choose to add 2x to both sides. There's a lot of steps you can take at this point, and they're all going to be correct. Personally, this is just the route that I've chosen. Okay, so these cancel. We end up with -14 equals 10x plus 66. And then now we're on a journey to get x by itself, right? So we're going to go ahead and subtract 66 from both sides. -66. So on the left, -14 minus 66 is going to be -80. And then over here, we end up with a 10x because these 66's cancel. So our final step is to divide both sides by 10 because we want to get x finally alone. So we get a final answer of x equals -8. All right. Next, we have cross multiplication. So remember, with these problems, when you have a fraction equal to a fraction, you got to find the diagonals. So here's one diagonal, and here, well, let's do red. Here's my other diagonal. Cross multiplication is literally what it sounds like, right? You multiply the terms in the diagonals and set them equal to each other. So in the red diagonal, I have 7x. And in the blue diagonal, I have 6 times x plus 4. Okay, once you've set it up, from there, it's just a very similar game as the one we played in the last problem, but this one's actually going to be simpler. It's a little bit less work than the last one. So now we're going to go ahead and just distribute on the right side. If there's anything to distribute, you just got to take care of it right off the bat. 6x, and then 6 times 4 is 24. So we'll just go ahead and get our x terms together. Let's go ahead and subtract 6x from both sides so that we can get those on the same side. So 7x minus 6x is 1x. And we have 24 on the right. So because we got x alone, it's technically a 1x, 7 minus 6 is 1, and that's the same thing as just x. So our answer is x equals 24. All right, final problem. This one, some people are still struggling with it, and it's going to keep coming back. So if we're trying to solve for y, that means we're trying to get y by itself. So all we have to do is move everybody else away from y. So our best thing we can do first is to move this 12x. Because it's positive, we'll subtract it from both sides. So they cancel here, and we end up with 3y equals 18 minus 12x. Notice how I did not combine these two terms because they are not like terms. I can't combine them because they don't both have x's in them, or they're not both numbers, right? They're different. Okay, the last thing I'm going to do, because remember, the goal is to get y by itself, I'm going to divide both sides by 3 because it's being multiplied. Ooh, I want green. So divide both sides by 3. And that's going to give me a final answer of this big giant fraction. But remember, if you can divide it, go ahead and do that. So 18 divided by 3 will give me 6. And then negative 12x divided by 3 will give me negative 4x. So that is it. Okay, that is all for today. This should be all you need to help you solve all the problems on today's practice.